Chapter 5 on exponents and polynomials. We begin with adding and subtracting polynomials. So our first definition is a blank is a single term or the sum of two or more terms containing variables with whole number exponents. The definition is for a polynomial. And there's a couple important bits in this definition. It's a polynomial because it can be a single term or many terms. Poly means it could be many terms. It's also the generic term, meaning anything with 1, 2, 3, 4, whatever, it's a polynomial. Okay? And the key part about being a polynomial is that the exponents do need to be a whole number. Okay? So far we've experienced linear polynomials in 1 and 2 variables. Okay, so let's list a few other types of polynomials in one variable. Okay, so first of all, let's give an example of linear, and then we'll talk about nonlinear. So we want one variable case right here. So linear in one variable would be something like 2x plus 4. Okay, nonlinear. Okay, if I want to make it nonlinear, the key to being linear was that the power on this x was only 1. So to make it nonlinear, I might need to say something like 3x squared minus x, or x to the 5th plus 2x to the 4th minus x cubed plus 1. Okay, that would also be nonlinear. It is polynomial because it's the sum of one or more terms containing whole number exponents. Okay, so some more definitions here. Blank is composed of numbers and or variables that have been combined using multiplication. Okay, so if it's multiplication only, not addition, we're talking about a single term. So a term is something that's only been set together with multiplication. For example, in the first nonlinear expression right here, there are two terms. The term is a combination of numbers and variables combined with multiplication. This subtraction sign or addition sign separates the expression into two different terms. A numerical coefficient, or just coefficient for short, is the constant multiple of the term. Okay. In a term with one variable, the degree is the variable's exponent. Recall that a term consisting of just a single number is called a constant. Alright, so let's look at the chart below. These are single terms. Notice there's no additions or subtractions, just a single term. And so for a single term, I can talk about its coefficient and its degree. In the term negative 5x to the 7th, the coefficient is negative 5 and the degree is 7. In 3x, the coefficient is 3 and the degree is 1. This is x to the first power, or a single x right there. In a squared, the coefficient is 1. You could write that as 1a squared, and it would be the same thing as a squared. And the degree is 2, since the exponent is 2. In 12, the coefficient is 12, that's the number, and the degree is 0. There are 0 x's there. What about for 0? For 0, the coefficient is 0, but the degree? The degree is actually no degree. 0 has no degree, and the reason for that is 0 is the same thing as 0x, is the same thing as 0x squared, and so on. 0 times anything is 0, so I don't know what the degree might be. I just have to say that 0 has no degree. Okay? Some more definitions here. The degree of the polynomial is the blank degree of all the terms. It's the highest degree of any of its terms. Polynomials are often written in descending order. Descending order is the order in which the variable's exponent decrease from left to right. If a polynomial has degree 1, we know it's linear. We've heard that definition before. We'll call it linear. If a polynomial has degree 2, we call it quadratic. Don't be confused with quad, meaning 4. Quadratic is for degree 2. Quartic would actually be degree 4. And degree 3, we'll call it cubic. Okay. Alright. So, some of these expressions right here are not written in standard or descending order, so we're going to need to rewrite them. For example, this first one, 3x minus x squared, is not in descending order because the highest exponent is not first. So we'll rewrite it with the highest exponent term first. So it would be negative x squared plus 3x. Okay. The degree of this polynomial is 2. That's the highest of any of the exponents. And because 2 is the highest degree, this is quadratic. Right, this one needs to be rewritten in descending order as well. The highest power is negative 4x to the 5th. 5 is the highest power. Then I go next highest power is going to be the minus x to the 4th. Then the plus 2x cubed. Okay, so I've gotten 5, 4, 3. No x squareds, so I'm going to do plus 3x next. Minus 6. Okay, and the degree is 5. 5 is the highest exponent. I'm going to have to say none. It's not cubic, quadratic, or linear. It's quintic, if you want to know the word for it. But in this section of this chapter, I'm just concerned with these 3 types right here. So I'm going to say it's none of those available. Okay, and for the next one, it's already in descending order. So I can just copy that over. X cubed plus 20x. Plus 5, it's already in descending order. The degree is 3. Highest degree being 3 makes it cubic. And lastly here, our highest power is x to the 4th. So I start with 10x to the 4th plus 8x squared plus 6. The highest degree is 4, so the degree is 4. And of these choices, again, it is none. Cubic is 3, quadratic is 2, linear was 1. And this one happens to be quartic, but that's not one of my options, so I'll say none. Alright, some more definitions. A polynomial with exactly one term is a monomial. A polynomial with exactly 2 terms is a binomial. And a polynomial with 3 terms is a trinomial. Alright, and we'll use these definitions on the next page to fill in this chart. Okay, the first one's already done for us, the trinomial. The second one is a binomial. There are 2 terms. The third one's a monomial, just 1 term. Now, the fourth one is actually going to be not a polynomial. And it's not a polynomial because we're not allowed to have any x's on the denominator. So that one's a kind of a trick question. There's 3 terms, but it's not a polynomial at all because of that piece right there. Okay. This one right here, I don't get to check anything because it is a polynomial. I'll make myself a new column. It is a polynomial, but it's not monomial, binomial, or trinomial. It's just some generic polynomial. And last one again, it's not monomial because remember we had to have whole number exponents. No negative exponents allowed to be a polynomial. So that one is not a polynomial either. Okay, some more definitions. Blank are terms with the same combination of variables with the same exponents. We're talking about like terms here. So like terms. In like terms, only the coefficients may differ. So list examples of terms that are like 9x squared. Well, it would have to be something that had an x squared in it, like 3x squared, negative 7x squared, 2/3 x squared. Anything that has an x squared in it. Unlike 9x squared would be something that had maybe 2x, the x is not squared, or 2x cubed, or even 2 over x squared. If the x squared is in the denominator, that's not like either. Okay. Now once I have like terms, I can add them by adding their coefficients. So negative 6x cubed plus 8x cubed, it's going to be 2x cubed. Just add the coefficients and keep the term the same. And the next one, we're going to add this as well as making sure we write the result in descending order. So I'm going to start with the highest power. So my 5x cubed and my negative 9x cubed will add to negative 4x cubed. Then my x squareds, 4 plus 3, will be 7x squared. Okay, looking for the highest power here, I see some 3's. Okay, so 2p cubed plus 4p cubed is 6p cubed, minus 1p cubed is 5p cubed. P squareds, negative 7 plus 8 will be plus 1p squared. and plus 2. That constant term is just going to stay on the end right there. Constants are always last, and when I write things in descending order. In the next objective, we're looking at adding two polynomials, and this is going to turn out to be exactly the same thing as combining like terms. These are two polynomials separated by parentheses, but the parentheses don't really mean anything, they're just grouping them. So let's just go ahead and combine the like terms to add them up. So I've got 4x cubed minus 2x cubed, or plus negative 2x cubed, is a total of 2x cubed. Then a negative 8x squared plus a negative 5x squared will be a negative 13x squared. Alright, 5x cubed, there are no other x cubed terms, so I'm going to lead off with 5x cubed. Next, I'm going to look at x squared. There are no other x squared terms, so I'm going to come up next with plus 7x squared. Then I've got a negative x plus a negative 2x for a negative 3x. And our last one here, 2x cubed plus 5x cubed is 7x cubed. Negative 7x squared plus negative 3x squared is negative 10x squared. Negative 9x plus 6x is negative 3x, and 1 plus negative 4 is negative 3. Now in the next objective, we are subtracting polynomials, and here I do need to pay attention to those parentheses because the negative from the subtraction does need to be distributed. So let's rewrite this. This is 2x squared minus 7x minus 4x cubed minus 5x. Now we'll combine like terms since we've already distributed that negative, starting with the leading term of negative 4x cubed. Next we'll go for the x squared, so we've got 2x squared, and finally negative 7x minus 5x is negative 12x. Right, same thing on the next one. Let's rewrite first by distributing that negative, making sure that all terms in the second parenthesis are multiplied by a negative 1. So the first one is just the same, no changes there. And the next one we have minus 5a cubed minus 4a squared. Negative, negative, we'll make that last one plus 2a. So leading term, negative 3a squared minus 5a squared is negative 2a squared. Oh, cubed. Those are cubes, my bad. Next, I'm going to look for a squareds. Here they are. Negative 5a squared minus 4a squared will be negative 9a squared. And finally the a's, 7a and 2a for 9a. And the last one here, distribute the negative, starting with 6x squared minus 4x plus 8 minus 9x squared minus x plus 2. So like terms, we've got 6x squared minus 9x squared is negative 3x squared. 4x minus x for minus 5x, and 8 plus 2 for 10. In the next example here, we're looking at a combination, addition, subtraction. So for the subtraction part, we'll distribute, and then we'll just make sure that we combine all of our like terms. So we've got 5x cubed minus 3x minus 4x cubed plus 7x squared minus x, making sure we distributed that to all. Then we just have the plus 2x cubed minus 6x squared. Alright, like terms, all the x cubes. Here's 5 minus 4 is 1, plus 2 is 3, x cubed. X squareds, here's 7 minus 6 is 1, so plus 1x squared, and x's, negative 3 minus 1 is negative 4.